Hello and welcome to 2.6 Notes, Day 9, Algebra 2 Trig, Linear Inequalities, and Two Variables. Let's get started. Example 1. Check whether the given ordered pair is the solution of 2x plus 3y is greater than or equal to 5. In order to check if an ordered pair is a solution to an inequality, we're going to label our ordered pair. All ordered pairs are given in the order x comma y, so those are the two numbers we're going to use to substitute into our inequality. So 2 times 0 plus 3 times 1, is that greater than or equal to 5? 2 times 0 is 0, 3 times 1 is 3, is that greater than or equal to 5? Well, 0 plus 3 is 3. Is 3 greater than or equal to 5? No. Therefore, this ordered pair is not a solution to the inequality. Let's try B. This is x, and this is y. We're going to do the same thing. Substitute 4 in for x, and substitute -1 in for y. Now let's find out if this is greater than or equal to 5. 2 times 4 is 8. 3 times -1 is -3. Is that greater than or equal to -5? Excuse me, just 5. 8 minus 3 is 5. Is 5 greater than or equal to 5? Yes. The reason why is because 5 is equal to 5, so it works. This ordered pair is the solution to the inequality. Let's try C. X and y. Substituting 2 in for x, and substituting 1 in for y. We're going to find out if this is greater than or equal to 5. 2 times 2 is 4. 3 times 1 is 3. Carrying down the rest, 4 plus 3 is 7. Is 7 greater than or equal to 5? Yes, 7 is greater than 5. So this ordered pair is also a solution to the inequality. Moving on to the next part. You can graph an inequality by following these steps. Find the x and y intercepts of your inequality, or put it in slope-intercept form. It's really up to you how you want to do this. To find the x and y intercepts, you substitute in 0 for y, since all x-intercepts have a 0 for their y, and you substitute in 0 for x when it comes to your y-intercept, because all y-intercepts will have a 0 for their x. Okay, second step, graph the boundary. Determine whether it should be solid or dashed. Solid means included, and dash means not included. So a dashed line, therefore, would be a less than, or it could be a greater than. Those mean not included. Whereas a solid would be less than or equal to, or it could be greater than or equal to, because those mean included. Test the point in the region not on the boundary line in the original inequality. If it's true, shade that side of the boundary line. If it's false, shade the other side of the boundary line. Okay, let's put these steps together and actually complete some problems. So looking at A. Graph the linear inequalities in one or two variables. A says y is less than -2. Students sometimes get stumped here because this is missing an x value, so therefore they're not quite sure what to do. This is a horizontal line. Okay, it is a horizontal line, and it is going to cross the y-axis at -2. So we know it's going to cross somewhere around here. We have to ask ourselves, is it going to be dotted or dashed, or is it going to be solid? And because it is a less than sign, it is going to be dashed. So we will put a dashed horizontal line right here. Then you're supposed to pick a point and substitute it in and see if it works, if it's true or false. I love to pick the origin. I love to pick 0, 0. It's just the easiest thing to check. So if I substitute this in, this is x, this is y. Don't get all confused because there's not an x, that's okay. Let's just substitute in the y. is y less than negative 2. Okay, so is 0 less than negative 2? No, it's not. So we are not going to shade this side. This was false. So we shade the other side, just like this. And it goes all the way up to the dashed line. I think you guys get the point. Let's go over to B. Graph x is greater than or equal to 1. Again, students get confused on these, but it's just a vertical line. Next thing, is it dashed or is it solid? Since this has an or equal to in it, it's going to be solid. So we go to 1 on the x-axis, and we're going to draw a solid vertical line. At this time, you pick a point and you test it. I love to pick the origin, which is 0, 0. It's just the easiest thing to check. This problem doesn't contain a y, but that's okay. X is 0. Let's substitute it in. Is 0 greater than or equal to 1? No, it's not. Do not shade the side where your test point is then. You're going to shade the other side. And it goes right up to this line. Just shade it the best that you can. Moving on to part C. Graph 2y minus 3x is less than 6. This is a little different. We have an x and we have a y. You're more than welcome to get this in slope-intercept form, y equals mx plus b, but I think it's a little bit easier sometimes to use x and y intercepts. So first let's focus on our x-intercept. When it comes to x-intercepts, we're going to substitute in 0 for y. Any point that falls on our x-axis is going to have a value of 0 for the y. It doesn't matter where it's at. You don't have to worry so much about the greater than or the less than symbols whenever you're doing this, so I'm just going to put an equal sign instead. Substituting in 0 for y, we receive negative 2 for our x. So I'm going to pop a dot, plot it, and move on to the next part. Let's find our y-intercept. You're going to substitute in 0 for x. When we do this, 2y minus 3 times 0 equals 6. So 2y equals 6. When we solve this, y equals 3. So on the y-axis, you're going to plot the 3. We have to figure out if this is going to be dashed or if it's going to be solid. Since it's a less than sign, it's going to be dashed. You're going to dash your line right between these 2 points. Then you're going to pick a test point. I'm going to pick 0, 0. It's just the easiest to substitute in. So 2 times 0 minus 3 times 0. Is that less than 6? Well, if I work this out, we have 0. Is that less than 6? Yes, it is. So, where my test point is, I do shade that side. The test point works, shade the side where the test point is. So you would shade all of this in. Okay, moving on to the back of our notes. You have $200 to spend on CDs and music videos. CDs cost $10 each, and music videos cost $15. Write a linear inequality in 2 variables to represent the number of CDs x and the number of music videos y you can buy. Okay, well first let's talk about the number of CDs. And then we're going to add to that the number of music videos. That should give us how much money we spent. Speaking of the CDs, how much were they? $10 each. So 10x will represent the number of CDs we purchased. X will be number of CDs. For the music videos, we spent $15 each. So we'll say that's 15y. Y stands for the number of music videos. And altogether, we're spending $200. But wait, are we? 10x plus 15y represents how much money we spent on music videos and on CDs. We only have $200, so we can only spend exactly $200, or we have to spend less than $200. Now we have an inequality. Let's go to part B. Graph the inequality. Discuss 3 possible solutions for the real-life situation. Okay, to graph the inequality, the first thing I'm going to do is find my x-intercept. To find your x-intercept, you're going to substitute in 0 for your y. I'm not going to worry about my less than or equal to here. I'm just going to set it equal to 200 so I can find that intercept. When we do this and we solve, we have that x equals 20. To find the y-intercept, we're going to substitute in 0 for x. When we do this, it does come out to be a decimal or a fraction. I'm going to leave mine as a fraction, 13 1/3. Looking at the graph, we're not going to be able to go by ones, but we should be okay if we go by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, let's do the same over here. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, let's go ahead and plot our 20 on the x-axis, and then we can plot 13 1/3 on the y-axis. It's going to look a little weird, it's in between there, but that's okay. Because we have a less than or equal to, this must mean we have a solid line. So do your best. Maybe use a piece of paper that's folded over as a straight edge and draw your solid line. The next thing we have to do, find a test point. I like to use 0, 0, the origin. It's just the easiest to check. Substitute this into your original inequality and see if you get something, a number less than 200. Is 0 less than or equal to 200? Yes, it's definitely less than 200. So we're going to shade. Now watch. I'm only shading this portion of the graph. I know that 0, 0 would be basically this whole side, but let's think about it. Over here, if I have a point, I'm saying that I have a negative amount of x, right? And a positive amount of y. Well, if I had a negative amount of x, doesn't x stand for the number of CDs? Can I have a negative amount of CDs that I purchased? No. Think about here. Can I have a negative amount of CDs and a negative amount of music videos I've purchased? No. And over here, positive amount of CDs but then a negative amount of music videos? That doesn't make any sense either. So in this situation, since it is an applied real-life situation, the only solutions that will work will be in here. Now you've got to pick some points inside. It says give 3 possible solutions for the real-life situation. Looking inside here, I'm pretty sure that 2, 2 is a point. 2 music videos, 2 CDs. What about 6 and then 1? That one will work. Oh, let's go with 4 and 8. That one will work. You know what? Even 0 and 13 and 1/3. But wait, why can I not use this? It falls on the line, it should work. Well, you can't buy 1/3 of a CD. So let's cross this one out. Can we say 20 and 0? Sure. 20 CDs, 0 music videos. You can use that one. It did say discuss 3 possible solutions, but I've given you 4 here. Just remember that X stands for the number of CDs. So in this situation, 2 CDs and 2 music videos. Here, 6 CDs, 1 music video. 4 CDs, 8 music videos, or you could even buy 20 CDs and 0 music videos. Any point that falls within the shaded triangle will work for this inequality and will be a solution to it. That concludes our notes. I hope you really enjoyed your time today. Goodbye.